Well, what that lets us do is it lets us then look at when we measure things. Um, we don't always need to know um, what the hundreds are. We might only need to know the thousands. For example, I hike a lot. You'll hear me talk probably after every Monday. I'll probably, I had a really good hike this weekend, or I got caught in the rain in the hike. I go out and I hike, and hiking is long distance. And I'll give an analogy. My son and I'm actually just going to put the camera on when I talk for a second, giving an analogy, because staring at a blackboard, a blank blackboard during things is probably not the best for everything. But my son and I, we hiked, my sons and I, we hiked Mount Abraham and Mount Ellen, which is an 11-mile hike. My son left his DS on, which tracks your steps. Now, the Romans used to say 2,000 steps or 1,000 strides was a mile. That's where we got our mile from. And mile comes from the Roman word for 1,000, milla. Military comes from that because there was 1,000 troops in a unit. Centurions were the 100 units. A lot of our language is around some of the numbers of organization. And my son left it on, and it tracked actually how many steps he did, like 22,000, like 360 some, if I remember correctly. It was 22,300 some. And I did the calculation and looked at my GPS watch, and my son had a perfect Roman stride. It almost converted equally into miles. But for an 11.5 mile hike, and I wanted to talk about how many steps we took, I just tell people he did 22,000 steps. What difference is 362 steps going to be in that? And so when we talk about numbers, we have this thing called the precision, how precise we need to be. And if you have more information than your precision, you want to round your numbers to that. So the 22,362 steps he did, well, I only want to be precise to this place. And so I would only say he did 22,000 steps. And so with our naming system, we also developed a way of rounding, or to say how precise we are. And what we're saying is, this stuff here doesn't give me any more information. It doesn't help me with measuring things. That's really going to be dependent on the thing you're doing, right? If I were building stairs, I would need to know down to the last step. But if I'm just hiking a large distance, I wouldn't. So the thing you're doing tells you the precision you need and where you would need to round. And so we're going to look at rounding rules. I don't like doing that, but I think it can be a little bit better instead of staring at a blank board like this. And so to round a number, we're going to underline the place to which we are rounding. All right, we're going to mark the number that matters to us, the level of precision that we're looking for. We look to the digit to the right, and we're going to make a decision. If that digit is 5 or greater, we add 1 to our underlying number. If that digit is less than 5, we leave our underlying number unchanged. Replace all digits to the right of our underlying number. With 0. So I'm going to use that hiking example again here, using these to round. So I used 22,362, and I wanted to round that to the nearest thousand. So I'm going to go over here, I'm going to rewrite things. 22,362 to the thousandth. So that's the level of precision I want. That's the place value that's going to give me the most information. So I look to the digit to the right. And I make a decision. And decision algorithms are perfect mathematical things. Notice we're not calculating, we're making a decision. If that digit is 5 or greater, we add 1 to our underlying number. If that digit is less than 5, we leave it alone. Well, it's less than 5, so we're not going to change this. And we replace all digits to the right of our underlying number with 0. So we leave it alone and replace with 0. And we have now rounded to the nearest thousand. Yeah, let's look at another number. $89,541, and I'm going to round to the nearest thousand. Again, I'm going to change color as I change function here. So 89,541 to the nearest thousand. So when I say underline, and I'm doing over bars, right? You need to mark the number you're looking at. I know some people put stars on them. The book says underline. I tend to do over bars. That's my apologies. I look to the number to the right. Is it 5 or greater? Well, yes, it is. This is bigger than 5. So I need to add 1 to my underlying number. Well, that's going to make it 10. And so that extra 1 comes over to the 8 here. Okay? When we have place values, if any digit gets greater than 9, the extra number comes over here. Adds into this column. That's the joy of place values, is 10,000s would be an extra 10,000, right? If this turns into 10, that 1 pops into this place. And then I replace everything to the right of the underlying number with 0. And so 89,541 to the nearest thousand is 90,000. And this is how we round. Rounding is very, very, very useful when we have information that is greater than what we need. Right? If I have a ruler and it only measures down to half an inch, I'm going to round everything to half an inch or even an inch, because there's no point in me having 1.367894 inches, because I can't cut that, I can't make it. And so rounding is a way of getting rid of the numbers that aren't going to help us. And it happens in very certain circumstances. You'll find as you do certain pieces of work in different fields, there will be different rounding conventions that work for the field you're in. They'll say always round to this number, or always round to this particular level of precision. And there are other ways of dealing with precision. There's significant digits and other techniques you can learn. But rounding is the start of that.